Hello guys, welcome back to my channel, Maison African Motives. Still working on engineering. Here we are going to be focusing on mathematics N5. Working on the question here, we are given the question from one of the question papers that we have got. All right, let me just try and push it this side. All right, so we are given in this case August 2021, which is question 5, the one that you're going to actually focus on. So we shall actually quickly rush through the questions and see what we are given in this case. So the first part of the question, we are asked on 5.1, which is 5.11, to make a neat sketch of the graphs. These are the two graphs that we have. Y is equal to sine theta, and y is equal to 1 plus sine x, that is sine x, and y is equal to 1 plus sine x in between 0 and pi. That is the part that we are supposed to sketch and to show the area afterwards. So let us start by just sketching these two graphs that we are given in this case. All right, so this is a 5.1. All right, let's just have it here. So we are given now on 5.11. The first graph is y is equal to sine x. All right, and the other one is of y is equal to 1 plus sine x. It was 1 plus sine x. And we are given the interval of x, which is greater than or equal to 0, less than or equal to pi. So this is very, very important for us so that we actually know where our graph is going to be in between. Okay, so as we know that the graph of sine actually is like this, the graph of sine x, just want to indicate the whole of sine x so that we can take just a smaller piece from there. We know that we have got something of this nature here. All right, so this is actually the graph of sine x that we have, where we know this is a 0 here, and at this value, it corresponds with pi over 2, and this is pi. We've got 3 pi over 2, and this is 2 pi in this case. Okay, so in this case, we just need from 0 to pi. That is the part that we need. Okay, so which means our actual graph is going to be like this. So we are just going to take this smaller piece only. All right, so it is going to be of this nature. I'm just going to take from here, from 0 to pi, so which means I just need this shape here. This is the only part that I need here. All right, so this is our 0 here, and this is our pi. And as we saw, in between here, we've got pi over 2. In between, we have got pi over 2, which is the maximum value, which actually corresponds here with 1. And this corresponds here with a -1. So in this case, this is going to correspond with a 1 here. So this is our 1 here. All right, so that's what you're going to have in this case. And if we are to cross-check here, it's now 1 plus sine x, which means it's just going to increase here. It was at 0 here. It is going to start at 1. This point was at 1 here, so we just add 1, so it's going to be 2. So which means we need a point here, which is a 2. Let's just indicate this side. All right, so let's just say this is where we have got our 2 here. Let's increase again and a 3. Okay, so let's just say that is what we are going to have. So take note, this is sine x, the original graph. So we are just adding 1 to the original graph. This was at 0 here, so it is going to add 1, which means it will be at 2. Pi was at 1, so if we add 1, it is going to be at what? It is going to be at 2. That is 1 plus 1, which is 2. At pi here, our graph was now corresponding with the 0. So 0 plus 1, it is going to be at 1. So it is going to correspond with 1 in this case. Okay, so which means our graph in this case is just going to be something of this nature. all right, up to that point. So that's what you're going to have in this case, where this correspond to pi here, and these two, they correspond to pi over 2, just like that. Okay, so let's just give the equations here. So this is the one of y is equivalent to 1 plus sine x. All right, and this is the one for y is equal to sine x. So that's what you're going to have in this case. So let's get back and see the region where we are supposed to indicate the area and so forth here. So we are given that after drawing this, show the area that is bounded by the graphs, okay, between the y-axis and the line x is equal to pi over 2, and the representative strip that you use to calculate the volume when generated, when it is going to rotate about the x-axis. All right, so it's going to rotate about the x-axis, so you're given in between 0 and pi. So definitely, guys, as we can see, in between 0 and pi, this is the area that we need here. This is the area that we are talking about here, in between 0 and pi. So this is the area that we're going to have. So let's just have our representative strip. Here it is best or fit to have our representative strip in this manner. All right, so this is going to be your representative strip in this case, all right, which corresponds to x. So it is going to be with respect to x, like that. All right, so that's what you're going to have, guys, here from so it's actually here you are having a combined thing here. You have to combine these two. So this is where you're going to have your area, something like that. Okay, so we're just going to name our graphs to say this is y1 and this is y2, so that it is going to help us to answer the questions which follow, because the other question now which follows is now for us to calculate the volume on 5.12. Okay, to calculate the volume described in 5.11, which is the volume generated when it rotates about the x-axis. This is what we are given about this volume, and it's actually 5 marks. So if it rotates about the x-axis here, we are seeing that our representative strip is for the x-axis and it is rotating about the x-axis. So these two, they are actually perpendicular, the representative strip and the axis of rotation, which is our x-axis, and the representative strip, they are perpendicular to each other. So that means this is actually disk method that you're going to apply. So we are going to use a disk method in this case. Do I have the formula sheet? The formula sheet is not there. I wonder what happened on this question paper, or I moved it. Okay, but anyways, we know that for our disk method, the volume is going to be given by this formula. This is 5.12. All right, this is 5.12. You know that volume, this is volume about the x-axis. So it is going to be equivalent to pi, the integral of y squared dx. This is our normal formula, remember, guys, in between. But because here there are two graphs that we are given, this is going to be y1 squared minus y2 squared. So that's what you're going to have in this case. So which means our volume with respect to x is going to be pi, the integral of limits a and b, and it's going to be y1 squared minus y2 squared with respect to x, as a normal. That's your normal formula for disk method, guys, as we know. So which means y1, that is the upper graph, this one which is on top, so it's the top graph minus the bottom graph here, which is on the bottom. So this is your y1, which is 1 plus sine x. So we are going to square 1 plus sine x here. So that's pi, the integral. What are the limits? Remember, our limits is from 0 to pi, from 0 here up to pi. These are the limits that we have got. So that is 0 to pi. And what we need is y1 squared, which we said it's 1 plus sine x. So it's 1 plus sine x squared minus y2, which is sine x squared. So that's what you're going to have in this case. So we have to simplify everything here. So let's just put it this way. okay, with respect to x. So we know, guys, from our identities that if we are to expand this bracket, we are going to be left out with Vx, which is equivalent to, all right, that would be Vx, which is equivalent to pi. We've got 0 here up to pi, and cross-checking is going to be 1 squared, which is 1 plus 1 times sine, which is sine times 2, which is 2 sine x plus sine x squared. So it's going to be sine squared x like that, okay? Minus, in this case here, is going to be sine squared x, just like that, okay? So as you can see, we've got something that is familiar that we can get rid of, which is the sine squared x and the sine squared x. These two, they can actually cancel each other, so which means we're going to be left with this part alone. So Vx is going to be pi. We've got 0 to pi here, the integral of 1 plus 2 sine x. So that's what you're going to have with respect to x in this case. So performing our integration, this is now a normal integration, guys. So our Vx is going to be pi. Let us integrate here. The integral of 1 with respect to x, that will be x plus, remember, sine changes into cos. So it is going to be minus 2 cos x. It's going to be a negative, this one. So it's minus 2 cos x. All right, our limits pi to 0 here. And if we are to combine here plus and minus, that's a minus. So which means we can conclude that our integral is going to be x minus 2 cos x. Okay, with the limits pi to 0 like that. Okay, so make sure that you make proper substitutions, and also that your calculator is supposed to be in radians. Whenever you're dealing with this pi, make sure that your calculator is in radians. All right, so that means your Vx is going to be pi. We just substitute the upper limit, which is pi here. So you're going to have pi minus 2 cos pi, close the bracket, minus the lower limit, which is a 0 here. So it's going to be 0 minus 2 cos 0. Okay, so whenever you're dealing with trig, do not assume that whenever there's a 0 here, your answer is going to be a 0. No, never assume that. Use your calculator properly, okay, so that you don't lose marks for assuming other things. All right, so our condition here is going to be something like 7 comma 1 4. That is what you're going to have in this case. 7, this part here alone is the one that I'm saying. It's going to give us something like 7 comma 1 4 1 3, something like that. 4 1 3. So it's going to be just 4 1 times pi. So it's going to be times pi. All right, so that will be our volume here, of which if we are to simplify this in terms of decimals, it can give us something like 22 comma 4359. So it's gonna be 436 if you round off properly cubic units. So take note, this is volume, guys. So that's why we have got our units here as cubic units. So that's what we had in this case. It was a matter of having your sketch. With the sketch that you're given, you substitute in the values that you are given and the volume and so forth. So let's see another question, guys, on 5.13 now. Here we are given now to calculate the volume moment about the y-axis as well as the distance of center of gravity from the y-axis, and that's actually 6 marks for that. Okay, so what do we know, guys, about the volume moment about the y-axis? So this one, it's a matter of formulas, and like I said, guys, this part is not having the formula sheet. I forgot to combine the PDFs. Okay, so anyways, let's see our formulas. We have got 5.13. Okay, so this is the volume moment about the y-axis, and it's between two given shapes. In actual sense, it was supposed to be volume moment about the y-axis is equivalent to the integral of r dv, that is by the volume. And here we are going to subtract because we've got two functions that we are given. So the volume moment with respect to y is going to be pi. We've got the integral of a and b in this case. So what is going to be our RDA? So it's going to be x into y1 squared. Remember, those two functions that we're subtracting, so we have to square them with respect to x. That would be the volume now. So it's area times x, that's volume, okay? remember from your normal mathematics, guys, whenever you've got area and volume, area and x, as area and x, it gives you volume. So if you've got volume times x, it gives you now the volume moment. That is the idea there. You can apply that concept even from your engineering science part where we had got moments and so forth. It was actually an application that you had to do in a separate way, but now you're doing it in a mathematical way. So that is the formula that you're going to have here. And it's just a matter of substituting, guys. As you can see, the volume moment with respect to y is going to be, the limits are still the same from 0 to pi. Remember the ones that we had here, 0 to pi. And y1, as you can see, this stage is still the same, y1 minus y2, this stage, this squared of this stage of y1 squared minus y2 squared is just one and the same thing. So we are going to repeat this stage here. All right, so we're just going to repeat that stage, but this time there is what? There is x. So it's going to be x into 1 plus sine x squared. So this is going to repeat minus sine x squared. So this part is just a repetition, as you can see, guys. So after expanding, we obtained something of this nature. So there, okay, let's just write, guys, was another question actually that you're gonna have. So after expanding these two, we ended up here. Let's get back here. We ended up with 1 plus sine 2x. If you cross check here, 1 plus sine 2x. So let's just write that stage. That is what we know we are going to obtain here, because this is a repetition, this one. So we ended up with 1 plus 2 sine x. Okay, 1 plus 2 sine x, sorry. 1 plus 2 sine x. This is what we ended up with. So what can we do to integrate this? Let's expand here by x and see what we have got. Okay, let's just try and expand our brackets. So we're going to have our volume moment with respect to y, which is equivalent to pi. Integral of, here we are going to have x times 1, which is x. Then we've got x times 2. Sine x is going to be 2x sine x. Okay, that's what you're going to have with respect to x. So this is your integral with respect to x. So as you can see here, we've got two terms. This part we can integrate direct, but here we can't integrate direct here because it's a product you're multiplying. So which means we have to think along the application of what? The application of by parts. So we have to apply by parts in this case so that we can be able to integrate this. So I'm just going to do an integral for this separately here. Then we will just take our final answer. So because of space, let me just do it here. The integral of 2x sine x with respect to x. So remember from our by parts that we are going to have this as f of x by gx minus the integral of f prime x gx dx, like that. Okay, so whereby this is our f of x here, f prime x. All right, this is our f prime x here, and this is our gx dx, this part. Okay, so that is what we know about this stage. Let me just try and increase a little bit. Okay, so that is f prime x, and this is gx. Okay, so it means in this case for us to, we have got f of x, guys. Sorry. I'm now mixing the two things here. This is our f of x, and this is our g prime x. I hope someone was seeing this. Okay, so we are saying that our f of x in this case is equivalent to 2x. All right, so our g prime x here dx is going to give us this part here, which is a sine x dx, like that. Okay, so now we can obtain f prime x, which is going to be the derivative of 2x, which is 2. And here to find gx, we are just going to integrate both sides, which is the gx will be the integral of sine. Remember, we talked about this. We said it gives us negative cos x. All right, so that's what you're going to have here. So let's just make our substitution part on this. All right, let's see what you're going to have in this case. All right, let me try to remove this part here. All right, so here we are going to substitute. Let us substitute our values. F of x, we said our f of x is 2x, so it's going to be 2x by gx, which is our gx is negative cos x. So this is negative cos x minus the integral of f prime x, which is in this case is 2. So you're going to have 2 by gx. This is our gx, which is a negative cos. So we are going to have a negative cos here, negative cos x dx. All right, so 2x times minus cos x here, this part here, let's write it here. It's going to give us negative 2x cos x. All right, then we've got this minus here, and this minus is going to be a plus. The integral of 2 cos x dx. So here we can have something like minus 2x cos x. If we integrate cos, remember it gives us sine, and it's a positive, so it's positive 2 sine x. Okay, so this is what we are going to have as our integral of this part, that is 2x sine x, but we have got x here, so now we can combine. So that means our volume moment is going to be here. Let's just write it here. So our volume moment with respect to y is going to be, take note here, we had pi. So we are going to write our pi here. So it was pi, the integral of, then we integrate x, and we know that x is x squared over 2. If we integrate this, we are going to have x squared over 2. Okay, and we combine with this part here, the integral of this part here, we obtained this, which is this part here. So we're just going to write this answer here that we got, which is minus 2x cos x. This is what we obtained, plus 2 sine x. All right, so this is what we obtained, and the limits that we got here, which is from 0 to pi. So these are the limits that we are going to use in this case, from 0 to pi. So having this, it means we can actually substitute just like the previous part, guys. We can make our substitution here when x is pi. So it's going to be pi squared over 2 minus 2 pi cos pi plus 2 sine x, which is 2 sine pi in this case. All right, so that's the first part that you're going to have in this case, minus the lower limit, which is a 0 here. So this one is going to be a 0, definitely, guys. That one is a 0 here. Here we've got x. This one is going to be a 0 also. Okay, the sine also. Okay, this one is going to be a 0 here. Yes, so this one we can actually have it by mere looking. Yeah, we can actually see, guys, sine 0 is a 0. So that's what you're going to have at the end. Let me just try to increase this part. Maybe it can be clear, this one. All right, so that's what we had here. Okay, so these are the limits that we have. And if you are to make proper substitutions on our calculator, we are going to see that the volume moment with respect to y in this case is going to be 1 here. This part, if you are to simplify this, is going to give us 11,217. Okay, times what? Times pi. Okay, of which we can just write this as a decimal, which is a 35,24347, and so you can round off. It's going to be 242, and these are now units to the exponent of 4. Remember, we multiplied volume times a unit, so it's going to be unit to the exponent of 4. That is your volume moment. So that is the case that we had here on this item. Okay, so let's try to reduce back. Okay, so let's get back now to this question that we had here. It was the volume moment and also the center here. as well as the distance of the center of gravity from the y-axis. Okay, so we need the distance from the y-axis, okay, which is from our volume moment. Is just a continuation, since we know that x bar is equivalent to the volume moment with respect to y over the original volume. So the volume moment we have got here 35 comma this volume moment 35 comma 242, so you just divide the two. Okay, so it's 35 comma 242, everything over the volume. Remember our volume, guys, the one that we obtained here, volume was 22,436. Okay, that's 22,436. Okay, so these are units to the exponent of 4, units to the exponent of 3. So definitely our answer is going to be basic unit there. All right, so that's what you're going to have. Take note, guys, we said this is what? This is 35 here. Okay, so that is what you're going to have in this case. So if we divide the two, we are going to remain now with the distance, which is in this case, I got something like 1,5707. Which is 1,571 units. Okay, so that's what you're going to have, because he is cubic and this is to the exponent of 4. You're going to remain with you. So that is the distance that we are supposed to obtain in this case. So these are the typical questions that you're going to have, and we have to work along the lines to see how we're supposed to answer these questions. All right, let's see another item. Another item here, which is on 5.21. 5.2. Okay, so 5.2, we've got 5.1. Make a neat sketch of the graphs y is equal to e to the exponent of x and y is equal to e to the exponent of minus x. Okay, so show the area bounded by the graph and the lines x is equal to 1 and x is equal to 3. Okay, so that is in between these values. Okay, so these ones you must actually know how the graph of an exponential function, guys, is supposed to be like. That's an exponential function, guys, is supposed to be like this. We know if it is a positive, if it is e to the exponent of x. Okay, sorry for this line. Okay, it's supposed to be something of this nature here. Okay, so if it is a positive, we are going to obtain our graph that is in this manner. So let me just try to at least change this part here. We know that e to the exponent of 0 is a 1, so it is going to pass through the y-axis at what? At 1. So it will be like of this nature. Okay, that is y is equal to e to the exponent of what? Of x, which is a positive, passing through the point where y is equal to 1 in this case. Okay, which is going to be opposed by the negative one. The one that is a negative, it goes, okay, just like that. Okay, so that is what you're going to have, and this is y is equal to e to the exponent of minus x, passing through the point where y is equal to 1 at this point. So that's what you're going to have, and the lines we are given to have the area bounded between these lines here. The line of x is equal to 1 and x is equal to 3. Okay, so that is what you're given in this case. So we are just going to make assumptions where our lines are going to be. So you're just gonna, if maybe this is our x is equal to 1 here, and maybe this is our x is equal to 3 here. Okay, so there we're just going to make assumptions, and we are saying this is 1 at this point, and this is 3. So which means the region that we are going to work with for our area is going to be this region here. This is the region that we are going to have in between the graph that we have got here. All right, so in between, that's where you're going to have our area. So the representative strip definitely is going to be of this nature in between this area Okay, we're going to have something of this nature here as our representative strip. So that's what you're going to have at the end. All right. So that is the part, guys, that you're supposed to indicate whenever you're answering this typical question. So that's your representative strip with respect to X and the lines. So taking note that, as we can see, we have got this graph here, which is on top of this. This is y is equal to e to the exponent of minus x. It's below this line of y is equal to e to the exponent of x. So, which means we can just name these to be our y1 and y2. We don't know what's going to happen later on. Maybe you're going to use to calculate area or so forth. So you just name y1 and y2. But that was just it for this question. And the other part now we are given to, this is 5.22. 5.22, you know, asked to calculate the area described in 5.21. Okay, so this is just area, guys. As we know, guys, area simply the integral of the given functions, just like that. But here we have to subtract. Okay, so we have to subtract because we've got two functions. Okay, so this is 5.22. All right, so area with respect to x is going to be the difference between the two functions. So we are going to have here a and b as our limits, and we have got y1 minus y2 with respect to x. So that's what you're going to have, whereby y1 is the one on top, which is e to the exponent of x. So you're going to subtract, so it's going to be area is equal to the integral of our limits here is from 1 up to 3. Take note this value here, guys. We say this is our 3 here. This is the line of x is equal to 3. Here x is equal to 1. Okay, so we're going to take from 1 up to 3. So that is our limits here from 1 up to 3. And y1, which is e to the exponent of x, which is this graph here on top, minus e to the exponent of minus x. So it is going to be e to the exponent of x here minus e to the exponent of minus x. So that's what you're going to have with respect to x. So as you can see, guys, this is e, where we can actually do a normal integral. The integral of e is, if it is e like that, it's just going to repeat like that. So it's be one and the same thing. If we're given e to the exponent of minus x, we know that it was supposed to give us e to the exponent of minus x over the first derivative with respect to x, which is going to give us a negative here. So there is a negative, and here we have got a negative here, so it is going to be a plus. So it's going to be e to the exponent of minus x, just like that. Okay, with the limits 3 and 1. So that would be your area in this case. So it's just a matter of substituting the values that we have got here, which is e to the exponent of 3 plus e to the exponent of minus 1. It's like that. So you can simplify this. Oh, sorry, guys, we have got two things that we have here. Where am I rushing now? All right. So we still have the 3 there, which is going to affect e on minus. So it's going to be minus 3. Okay, so let's just put it this way, minus. Then we put this one now, it's just going to be e to the exponent of 1 plus e to the exponent of minus 1. Yeah, something like this of nature. So let's simplify the first part here and see what you're going to have. All right, so from our calculator, guys, everything here is going to give us something like 17, 0.04 916, yeah, something like that. So if you round off, this is going to be 17,049, because this cannot change this value. So let's just say 0.49, yeah, something like that. This is area, and you know that area is measured in square units. So you can just write a square units or square units, whatever the way that you want. All right, so that was the area there. Let's see the other question. The question now we are given to calculate the area moment about the y-axis. This is area moment about the y-axis of the area described in question 5.1, as well as the distance of centroid from the y-axis. Okay, so That is what we had in this case. So you know that it's just a continuation, just like what we did previously. Area times what? Area times x. We have got area moment just like that. So it's going to be area times x. Okay, so we need the area moment about the y-axis. So it is going to be area, which is RDA. Okay, because already we've got area there. So which means area moment about y-axis, we've got the limits a to b, and it's going to be x times area, which is our area in this case was y1 minus y2. Okay, just like that with respect to x. So that means our area moment with respect to y is going to be, we have to substitute here a and b, which are those limits, the ones that we had, which was 1 and 3, just as it is 1 and 3 here. So it's going to be 1 and 3. That's 1 to 3. And we've got x into y1 minus y2 is still the same that we had here before. Y1 minus y2, which is this one, e to the exponent of x minus e to the exponent of minus x. So this one is just a repetition that we are going to have with respect to x here. All right. So in order for us to integrate, guys, as you can see, it's best for us to actually expand our brackets here, which is x times 1 here, which is going to be x e to the exponent of x. Then we've got x times minus, which is minus x e to the exponent of minus x, like that. Okay, so this is what you're going to have with respect to x. So making your integrals, as you can see, the best thing that we just have is the application of what? By parts. So we are just left with by parts in this case. So there's no way. We just have to apply by parts there. So let's see the first part. Let's just quickly separate these into two. Okay, so the first part, remember our formula, guys. I'm not like going to rewrite it down. Remember, this will be dx all. If maybe we can just do this so that we don't miss each other here. Maybe it can help us. Okay, maybe it can help us. Let me just separate these two so that we don't confuse each other. So you're saying here it's like this, guys. We are going to have the integral of I've got 3, 1 here, x e to the exponent of x dx, like this. Okay, minus, which is the same thing here. I've got 1, 3, and this is x e to the exponent of minus x dx. So as you can see, what I was trying to say is that if you are to use your by parts here, you're going to see this is your f prime x. This is your f of x, sorry, and your g prime x here. Okay, this is your f of x, g prime x. So we can actually take from the formula and just apply direct on our by parts formula, guys. Okay, so remember our by parts formula was whatever that you're going to have on the integral, it is going to give you f of x by gx minus the integral of f prime x. So we are going to have f prime x gx dx. Okay, so that's what we are going to have. So let's start with, let's just separate these two. Here, this is our f of x, which we said is x in this case, and our g prime x dx, oh sorry guys, dx is going to give us e to the exponent of x dx. So let us just find f prime x, which is going to give us 1 here, the derivative of x, that's 1. And if we are to integrate both sides, we are going to be left out with gx, and we know that the integral of e is going to remain like that, this one. Okay, so there's nothing here. So let's substitute into our formula. So f of x, we've got f of x, which is x times gx, which is our gx here, which is e to the exponent of x, minus f prime x. So it's now the integral of f prime x, which is just a 1 here. So it's just a 1 by gx dx, of which our gx is e to the exponent of x dx. Okay, so what are we going to have at the end? This is going to give us x e to the exponent of x minus the integral of e. This one still repeats itself. So this is what you're going to have from this part here, from this first integral. We shall combine these two, but from this, we are going to obtain this integral here. So let's do the same on this other part here. So we are going to have our f of x in this case, which you said is going to be x, and our g prime x dx, which in this case is this part of e to the exponent of minus x dx. Okay, so f prime x, in this case, we already calculated this, it's 1, and if you integrate both sides, we're gonna have gx, which will be equal to e. We say this is e to the exponent of minus x over the first derivative, which is minus 1. So it's going to be e minus e to the exponent of minus x, like this, because there's a minus 1 like that. Okay, so now let us just combine into our formula here. Our formula is f of x, which is x by gx, which is minus e to the exponent of x. So it's minus e to the exponent of minus x, like this. Okay, minus f prime x of, which is 1 here, so there's nothing here, so it's just a 1 times gxe, which is e to the exponent of minus x with dx. So that's what you're going to have. Take note, there's a minus here, so let's combine and see what you're going to have here. X and minus, that's minus x e to the exponent of minus x. You've got minus and minus here, which will give us a plus. But the moment we integrate this e to the exponent of minus x, it's going to give us a minus. Remember the integral of e to the exponent of minus x here, we ended up with a negative. So that means we are going to have a negative here. So it is going to be minus x e to the exponent of minus x, and this will be minus e to the exponent of minus x. Okay, so this is what you're going to have at the end from these two integrals. So we have to combine. We did this integral separately and the other one separately. So therefore, our area moment with respect to x is going to be the first integral here. So now combining this integral of x, which is the one that we did on this side, and we obtained this answer here. So this is the one that you're going to write, which is x. We obtained x e to the exponent of x minus e to the exponent of x. This is minus e to the exponent of x. Okay, whatever that we got, take note here, there is a minus. Here we are subtracting the other integral. So you're going to take this minus and subtract this integral here. So as we can see, if we are to subtract, or we can just write it minus, let's just subtract this. So it's going to be minus x e to the exponent of x. This is x not, this is minus x, guys, here. Okay, this is minus x here. As you can see, it was minus x here, minus x. Okay, so this is minus x there. So this is a minus x here. All right, so that's minus x on this part here. And we have got minus, this is minus here, e to the exponent of minus x, like this. All right, so that is what we had. And the limits from 1 up to 3, and our limits is 1 up to 3. So we can at least expand these brackets and simplify further. If there can be like terms, we can collect like terms if possible. So that will be, in this case, x e to the exponent of x minus e to the exponent of x. Minus and minus, that's a plus, x e to the exponent of minus x, minus and minus, which is a plus, e to the exponent of minus x. So as we can see, in this case, we do not have like terms, so we are just going to substitute our values, which is the maximum value minus the minimum value. Okay, so maximum is a 3 there, so which means our area moment with respect to y is going to be, substituting here 3, so it's going to be 3 e to the exponent of 3 minus e to the exponent of 3 plus 3 e to the exponent of minus 3 plus e to the exponent of minus 3. So that is the first part that you're going to have. Minus, we move on to when it is a 1, so it's going to be 1 by e to the exponent of 1 minus e to the exponent of 1 plus 1 by e to the exponent of 1 plus e to the exponent of minus 1. So this is minus 1 here. So that's what you're going to have. And our area moment with respect to y-axis, if you are to combine these two, we are going to have 39,634 46, something like that. Okay, so rounding off this, we are going to obtain something like 39,634 to just 3 decimal places. And this will be area moment, which is a cubic units. Okay, so that was our area moment, guys. With respect to y-axis, as you can see, the integrals and so forth. So that's what we had. And we have to be very, very careful about these integrals and so forth. Okay, so let's see, but it was also the area moment and also to calculate the distance, which is the centroid of the distance of the centroid from the y-axis in this case, which is a x bar, just like what we see on the center of gravity, that one. This one is a centroid. So it's going to be area moment over the area, just like that. So this one is area moment over the area. Okay, so we're simply taking our area moment, this one, 39,634. That is our area moment over the area. The area we got it here, which was 17,04. This one was our area. So it's 17,04. 17,049 square units. Okay, so that's what you're going to have, and our answer is going to be in units. So you're going to obtain something like 2,324,711, something like that. Okay, so if you round off, it's going to be 2,325. It's going to change here into 5 units. So that is what we are going to have in this case. So that was the distance, guys. Just like that, we have got your distance. So it's very, very important that you apply this concept properly so that you won't even miss any of the questions there. Okay, so let's see. On 5.3, which is 5.31, we are given the line y is equal to 4 intersects the graph of y is equal to 3x minus 3 squared at the points. These are the points. Sketch the graph and show the area bounded by this, and the line y is equal to 4. And the representative strip should be perpendicular. Take note to the x-axis, and it's in upper caps. So take note about that. Okay, so let us start by the graph of y is equal to x minus 3 squared. How does that graph look like? You're supposed to know this. It has got one point. Whenever you see a graph like that, which is a quadratic graph, it means it had a turning point this is y is equal to x minus 3 squared. So it has got a turning point at 3, 0 there. That is where it has got a turning point at 3, 0. Just multiply this by negative is 3. The value of y here we do not have, so it's a 0 there. So that turning point is also a solution to our graph. So it's a turning point and it's also an x-intercept. That is a solution, an x-intercept. So which means we've got something of this nature here. So the graph definitely is going to be of this nature. Okay, this is now too much. Let me just try and reduce this. Okay, it must just detect this at once. All right. So let's see. Let's try and put something of this nature here. Okay, guys, this is your quadratic function actually. So you can draw something which is much better, yes, because I'm still learning this thing. But that's what you're going to have, and it will cut or cross the x-axis at 3 here, and this is a 0 here. So we need to know at least this point, so forth. So we have got that when x is equal to 0 here, we know that when x is equal to that y-intercept, so it's 0 minus 3 squared which will give you a 9. So this will be at 9 here. But we are asked to draw the line of y is equal to 4 here. This is the line that we need. Y is equal to 4. If we are to cross-check on our question, we must draw the line of y is equal to 4. Then the perpendicular representative strip. So let's draw the line of y is equal to 4, which means this line is actually below this line because this is y is equal to 9. So y is equal to 4 is going to be below. That is why you need to know your graphs, guys. Okay, so y is equal to 4 is going to be below this line, something like that. Okay, so this is the point, and the point where these two are intersecting, and we are told that they intersect at 1, 4, and another one was 5, 4. So those were the points of intersection. So it means the 1, 4 is this one here. This is our 1, 4, and the 5, 4 will be this one. This will be our 5, 4. Since this is the line of y is equal to 4, so it means this point here is your 5, and this point here is your 1. So the area that we are talking about is this, which is in between these graphs. This is the area that we are going to have, and we are told that the representative strip is supposed to be perpendicular to the x-axis. So perpendicular, meaning to say our representative strip is going to be like this, perpendicular to the what? Perpendicular to the x-axis. So this is our representative strip with respect to x. The limits from 1 up to 5, just like that, guys. That is what we had. So we have got two functions. This is the graph of y is equal to x minus 3 squared. Remember that, guys. Okay, so this is our graph here. Our graph here, this is our y-axis. Okay, so that's what we had in this case, and the points, I think everything is there. Then let's check our question now. What are we given now to have or to determine from this? As you can see, this question, they're actually easier if you practice a lot of them. Okay, 5.32, you're now asked to calculate the area described in question 5.31, which is the one that you're given. Is actually 3 marks for that. Okay, so here, our area, we are going to see that there are two graphs that we have got here. So let's just name our graphs y1 and y2. Okay, so these are the two graphs. As we can see, y is equal to 4 is the one that is above this one. So this is your y1 and this is your y2. This is above according to this region, okay? Y1 is above and y2 is below. So which means our area is going to be like this, 5.32. Remember, whenever there is a function that is above another, your area is going, it was supposed to be yda like this. ydx, sorry, not ydx, but ydx. Okay, but now, because we have got two functions that we have, or two graphs, we're going to subtract, which is going to be y1 minus y2, just like that. Okay, so this is going to be y1 minus y2 with respect to x. So just like that, and our y1 in this case is this 4 here. So that is y is equal to 4. Remember, we are given the equation y is equal to 4 there. So area with respect to x is going to be the integral of the limits. Now we are given to take the limits from 1 up to 5. That is what we have got here, from 1 up to 5. These are the limits that we have got. At the point of intersection, you take your points at the point of intersection there, okay? That is 1 up to 5. And we said our y1 in this case is 4 minus y2, which is the graph that is bottom here. This one is the one that is below, according to this region. This is the one that is below the graph. So that is your y2, which is x minus 3 squared. So you're going to subtract x minus 3 squared. So you have to subtract this x minus 3 squared with respect to x. Okay, so definitely for us to have this integral, let us just try and expand our brackets and so forth, so that we, at least it can help us to integrate in a proper manner here. So we've got 5, 1 here, 4 minus, if I expand this, I'm going to have x squared minus 3 times 2, which is 6x minus 3 squared here, which is 9. Okay, so this is what I'm going to have with respect to x. Let's expand our brackets, guys, and see what you're going to have at the end. So we've got area which is equivalent to 1, 5. Expand our brackets here, which is going to be 4 minus x squared. This one is minus and minus, which is plus 6x minus and a plus, which is a minus 9. Okay, that's our area. And if we are to collect our like terms, we are going to see that our area is going to be, this is 5, sorry guys, this is 5, this is 1, like this. Okay, so 4 minus 9 here is a minus 5. So we're going to obtain minus 5 plus 6x. So it's just depend with the way that you're going to write it. Okay, so you can just leave it like that, or you can, I don't know guys, the way that you want. Okay, so here I could have just written this as a minus 5 plus 6x minus x squared is the one and the same thing, or minus x squared plus 6x minus 5. This is what I'm trying to say, that is one and the same thing. Okay, so our area in this case is going to be, let's integrate minus 5 to be minus 5x minus, here we are going to add 1 and divide by that, which is x to the exponent of 3 over 3. Okay, minus, here we've got 6x. So remember the integral here, it was supposed to be 6x squared. You add 1, which is over 2. So 2 into 6, this will give us 3. So it's going to be 3x squared. So that's what you're going to have. And don't forget the limits, 5 up to 1 up to 5. Okay, so that's what we had. And in this case, we can substitute the limits so that we can find the exact area now, which is minus 5 times upper limit. Start with upper limit, which is 5, minus 5 to the exponent of 3 over 3 plus 3 into 5 to the exponent of 2. So that's what you're going to have on the first part, minus, we move on to the lower limit. This is a 1, guys. You can simply see here that when there is a 1, we can actually, okay, sorry guys, I'm even worsening. I'm trying to remove and I'm worsening. Okay, so what I was trying to say is that you can, by just looking at the question, you can see that here, if you substitute a 1, it is going to be minus 5 here, a 1 here is going to be minus 1 over 3, a 1 here is going to be a 3. So by just looking at this, we can clearly substitute our values. Okay, so our area is going to be, if we simplify properly, the first part is going to give us something like 25 over 3 minus the second part, which is going to be minus 7 over 3. Okay, so that's what you're going to have in this case. So if you combine these two, it is going to be 32. That is 32 over 3. Yeah, 32 over 3. And that is square units, or you can just write it as a decimal. This is square units, guys, or as a decimal, it's going to be 10,666 and so forth. Okay, so if you round off, it's going to be 10,66, and this 6 is going to change this into 7. So that's what you're going to have in square units. So that is your area with respect to x. So that's what we just had from this part. And as you can see, guys, it's just a matter of repetition that we are just having in this case. You see that the other question is just a repetition also. You see that these questions are just repeating. Okay, let's see, 5.33 now. Calculate the second. Okay, this one is list. It's the second moment of area about the y-axis of area described in question 5.31. So take note, guys, we are working with the second moment of area, which is I, where we got, okay, let me just have this down, second area moment. Okay, so let's check our graph first. Okay, we've got two graphs here in between and the representative strip with respect to x. So which means our area, our second area moment is going to be 5.33. We've got I, y, which is equivalent to the integral. This was supposed to be our formula in actual sense, r squared dA, because this is second moment. So whereby this is simply x squared times what times area. Okay, so that is what we simply mean. It's going to be the integral of the limits do not change, still from 1 to 5, and that's going to be x squared times area. And our area in this case, we have got two graphs. It's going to be y1 minus y2. Okay, so that's y1 minus y2 with respect to x. So remember your formulas, guys. So this is y1 minus y2 with respect to x. So this is a repetition again. So that is iy, which is equivalent to 1, 5. Here we've got x squared times, we have to multiply y1 minus y2 this time, which is y1 minus y2. Guys, I'm just going to take the part that we had after simplifying. Okay, or we can just save it. Just save it from the beginning. This one, just take this part and so forth. Because some of us might want to have this from the beginning. So let me just save it. It was 4 minus x minus 3 squared, like this. Okay, so what you're going to do, guys, you're going to expand everything, the brackets, just like what we did previous, because as you can see, this is what we expanded before. So you expand until this stage. So here I'm just going to put this, expand until this stage, 5, we've got x squared, and we ended up at this stage here. This is where we ended up here at this stage before integrating this one, which you had got 5 minus x squared minus plus 6x, like that. Okay, so this part that you're going to take. So it was minus 5, okay, minus 5 minus x squared minus 5 minus x squared plus 6x, if I'm not mistaken. Yeah, that was plus 6x. Okay, with respect to x. So let us expand the brackets here. So it's going to be what? If you expand, it's going to be 1, 5 here. So it's x and 5 minus 5. So it's going to be minus 5x squared. Okay, this is going to be x squared. And this is going to be minus x to the exponent of 4. We're going to add the exponents. 2 plus 2, that's 4. Plus it's going to be x squared and 6x here, which is 6x to the exponent of 3. Okay, so this is what you're going to have as your integral with respect to x. So if we are to integrate this, our area moment, our second area moment is going to be, okay, let's just integrate and see what you're going to have. This is minus 5x to the exponent of, so you add 1 here, it's going to be minus 5x to the exponent of 3 over 3. Okay, if we add 1 here, it's going to be 5, so it's minus x to the exponent of 5 over 5, and this is 4, so it's going to be 6x to the exponent of 4 over 4, and if you reduce this, this is by 3 over 2, so it's going to be 3 over 2 actually. Okay, so it's going to be plus 3 over 2, this is x to the exponent of 4. All right, and your limits, guys, 5 up to 5 and 1. So take note of your limits and so, or you can even write it as 6 over 4. There's no problem, or you can write it as 3. Guys, it's just one and the same thing. Do not worry about that one. Okay, so now substitute your values, the upper value minus the lower value in this case, which is our upper value, is 5. So it is going to be minus 5, 5 to the exponent of 3 over 3. Minus 5 to the exponent of 5 over 5 plus 3. Okay, this is 3, guys. Okay, this is 5 to the exponent of 4 over 2. Okay, just like what I said, you can actually reduce the way that you want, or you can leave it like that. Okay, this is 1. You can simply see that this is 1, so it's going to be minus 5 over 3. Here is going to be 1 to the exponent of 5, which is minus 1 over 5. This is a 1 here, which is going to be just 3 over 2. So this is what you're going to have at the end. You just combine your values. So you've got IY, which is, in this case, this part is going to give us something like 625, guys, 625 over 6. So this is 625. 625 here. Okay, so this is 625 minus, and this is going to give us a negative, which is 11 over 30, if I'm not mistaken. So you just cross-check also your values and so forth. But our area, second area moment is going to be 104. If we round this, it's going to be 104,5, 3, 3, 3, 3, 3, 3, and so forth. So just 3, 3, and this is to the exponent of 4. Okay, so that's what we had on this part. Okay, so that was 5.33, guys. So let's see other parts, and if we can be able to finish up, guys, because now there's a lot of background noise there, so I don't know if it is not going to affect. On 5.14, you're asked to there's a cross section of a water canal of a shape of a trapezium. So this is a trapezium, guys. Take note if you are dealing with a trapezium. There's a sluice gate here of height 3 meters. Is used. Take note, there's a height of 3 meters, which means between the gate, and the gate is 4 meters wide at the bottom and 8 meters wide at the top. The height of water in the canal is 5 meters. Okay, so this is the height. I'm just going to make a sketch, then we'll do it. So this is the height of the water, which is 5 meters. So we've got 5 meters here. But this one, a sluice gate here, is what? Is 3 meters of height. So which means it is going to be from -5 here, from -5, this is our -5 here, up to this point, we must have 3 meters. So for us to have 3 meters, we are going to just add like -5 plus 3, which is going to be at what? At -2. So this is going to be at -2. So the height of the sluice is this one. This is the height that you're talking about. It must be 3 meters. In between, there must be 3 meters. So actually, it's a question which is simply saying, here it is like 2 meters below water level, just like that. Okay, so they didn't mention that, but because of this information, we can take note. And here we are told that on top it's 8 meters, here 8 meters wide on top. So this will be 4 here, and this will be -4. And it is 2 meters wide at the bottom. So this is your bottom here. So it's going to be 2, 2. So it's going to be divided into 2 here. In between, we are going to have 2 units. So that means we've got points here. This point here is going to be 4 -2. Okay, let me write this clear. I'm going to redraw this. I'm just showing you a sketch of what we're supposed to have actually. Then now our diagram can be easier. So this is going to be 4 -2. And this here we said is 2 in between. So it is going to be 2 and -5. Okay, so that is what we have, guys. Your representative strip and so forth and so forth. So here I'm using it below the what? Below the x-axis. So our x-axis is our water level in this case. Okay, so that's what we had, guys. We just did this sketch in it there. So something of that nature. So take note when you're attempting these questions, guys. So we had something of this nature, guys, on our sketch. If we were together, we said we are going to end up with, no. This application, does it not have a ruler or something? We have to check. That I'm learning also to use these things, guys, as we know. And everything has to be learned. Okay, so this is what we said we are going to have. Actually, I was just supposed to have my bigger line, but anyways, it's fine. So as you know, the shape, that the way that is supposed to be, is going to be also easier for you to even what? Construct your diagrams. Okay, so this is your trapezium here, guys. All right, so we had something like this. We said this is -2. I want you to cross-check this part here, to take this part, guys. This is the one that I'm referring to here. Right, or this part. Okay, so you said here we are going to have -2 up to -5 because it must be 3 meters in between. Okay, so take note about that. All right, so we've got -2 up to -5. This is where we are going to start this gate here. All right, so let's just put it this way. So we said we've got -2. Oh, let me change. -2 here. So this is our -2. This is our -5. So that in between here, this is the height that I'm saying there must be 3 meters in between. Okay. So anyways, this is our x-axis and our y-axis. All right, and we're gonna have our representative strip here. Okay, so next time I'll try to check out how to use this application much further, guys, so that it can be at least a little bit fine. And here we agree that it's 4, and we say this point is going to be 4 minus 2, and we also agreed that this is going to be 2, and this point is going to be 2 minus 5. Okay, so this is just your sketch, the one that you're going to have, so something of this. So I'm just working with this side. Yes, you can indicate this because you know that these two will be equal and so forth. So that's what you're going to have in this case. And we can just attempt our question now. All right. So the question was just to sketch here, and I think everything is there. If there's something that we missed, because as you know, these things now, you can miss anything slightly here, but you just have to cross-check if we didn't miss anything from this part. Okay, so here now the question is to calculate the first here. Okay, here we're just asked to make a neat sketch just like that of the area and so forth. Okay, so now we are asked to make after that on 5.22 to calculate the first moment of area of the gate and the water level. That is 5 marks for that. Okay, so let's see, guys, what we are going to have on the area there. So in this case, we can actually just apply our formula. So let's just see. Let's just extend this part here. Pages are now 2 men. Okay, so we know that our area, guys, is going to be from this part. Let's just see, this is 5.42. Okay, so as we know that this is area, but we need the relation first between x and y. So let us start by the relation between x and y. Okay, so our relation between x and y, we are going to use these 2 points here. So make sure that you've got a neat sketch, guys. You're going to have these 2 points, which is 4 and minus 4 minus 2. And the other point, which is 2 minus 5. Okay, so these are the 2 points that we are going to use in this case. So remember the relation, we have to calculate the area. We have to calculate the length of the line that is giving the equation of that line, which is in this case, using these 2 coordinates, we can just find the gradient first, then we formulate our equation. Remember, guys, your x1, y1, x2, y2. So m, which is the gradient, is given by the formula y2 minus y1, in this case, everything over x2 minus x1. So we can just have here our y2, which is -5 minus y1, which is -2. In this case, everything over x2, which is 2 minus x1, which is in this case, it's a 4. So if you are to simplify properly, we are going to obtain 3/2. So this is your gradient, which is m, as we know that our equation is given in the form of y is equal to mx plus c. So we can substitute our gradient here, which is 3/2. So that means y is equal to 3/2x plus c. So to find c, guys, you know that you have to substitute any one of these points. So let us just take any point of our choice. We can even choose to use this one, 4 minus 2. When x is 4, y is minus 2. So when x is 4, y is minus 2. That means in place of y, we've got minus 2. In place of x, we have got 4. That is what it means. Plus c here. So it's gonna give us 2 here, which is 6. So to this side is minus 2 minus 6, which is going to give us c. So c is -8. So this is what you're going to have. So having our equation, remember we said y is equal to mx plus c, where we had y is equal to 3/2x. So it's going to be 3/2x. Okay, so this is 3/2x plus c, which is our c. In this case, we obtained -8. So we have got -8. And remember, our relation must be of x. We must make x to be the subject here. So how can we make x to be the subject? Just multiply by 2 here so that we can clear the fraction here. So we can clear this fraction. Is going to be 2y, which is equivalent to 3x minus 16. 8 times 2, which is 16. So we can transpose this to the left-hand side. That's 2y plus 16, which is equivalent to 3x. So you can divide by 3, by 3 each and every term. Because remember, we want to make x to be the subject of the formula. So x is going to be 2 over 3y plus 16 over 3. So this is your relation, the one that you are now going to use to calculate your area moment. So for this part, guys, I think you just know how to find this relation and so forth. Okay, so after the relation, guys, then let us find our area from our first area moment. Remember, our first moment area will be of this nature. First moment. Right, let's just put it this way, which is equivalent to the integral of RdA. And these formulas, guys, I've actually explained these. So just have to work on them and to revise as much as you can. So this is going to be y times 2x. This is the formula that you're going to have in this case. So let us now substitute our values, our x in this case, which is this one, that is our x. So it's going to be 2 times x there. So which means we are going to have our limits. Remember, our limits now, we have to look at this part here. This is our get from -2 here. This is -2 up to -5. So these are the limits that you're going to have. Okay, so we are going to start. Our minimum value is -5 and our maximum value is -2. Okay, then we have got y times this part here. Okay, so this is just y here. Okay, times 2 times x. Our x, take note, your x is this part, which is the one that I circulated there. So you just repeat that stage as it is, which is in this case, it was 2y over 3 plus 16 over 3. So that is the stage that you're going to have with respect to y in this case. So yes, you can expand everything so that you'll be able to integrate in this case. So let us just expand by 2y in this case. So if you multiply this, you're going to have 4. That's 2 times 2, which is 4y times y here is going to give us y squared over 3. All right, then we move on here plus. If you multiply 2 times 16, that's going to be 32. So this will be 32y over 3. So that's what you're going to have in this case with respect to y. So let's integrate, guys, and see what you're going to have at the end, because this is just a matter of integrating now so that we can have our first area moment, which is in this case, we've got y to the exponent of 3. If we add, it's going to be 3. So it's 4. Y to the exponent of 3 over that 3 has to multiply with this 3. So it's 3 times 3, which is a 9 there. So take note of the working that you're going to have. Plus, in this case, this is going to be 32. We add here is going to be y squared. If we add, so it's going to be 32 y squared over, if you multiply by 2 here, because it's now y squared, is going to be 6. Okay, so you can reduce this. Yes, it's fine. You can actually reduce this, or you can just substitute your values because you've got the value of y, the maximum value, which is -2 here. So that is going to give us 4 into -2 cubed, everything over 9, plus 32 into -2 to the exponent of 2, everything over 6. So that's what you're going to have. Minus, we move on to the lower value, which is -5 in this case. So it's 4 into -5 cubed, everything over 9, plus 32 in this case, that's -5 to the exponent of 2, everything over 6. Okay, so just don't mind this part, guys. This is -2 squared here. All right, this is minus 2 squared. It's like this pen, it needs me to write slowly so that it can actually sense my handwriting. So it's very, very unfortunate that I don't write slow, guys. And I don't know how am I going to fix this problem. So anyways, we have to expand everything. So the first part, I got something like 160 over 9. This is 160 over 9. Minus the other part got something like 700 over 9. Okay, so this is 700 over 9. So subtracting these two, we are going to have negative 60. This is cubic meters, because remember the units, we are told that it's meters and so forth meters. So definitely your answer is going to be what, in cubic meters. If it was just units, therefore you use the units as they are. But that is what we had in this case. So that was our first area moment. As you can see, guys, it was actually a lot of calculations, but you have to be used especially in exam, because that's what you're going to have this part. Okay, then the last part on 5.43, we are now given to calculate the depth of center of pressure on a solid skate if the second moment of area of the gate above the water level is given as 213 units to the exponent of 4. And that's just 1 mark here. Why is that so? Because we know that y bar, that will be second bar, because this is now you'll be having the second moment, second area moment over the first area moment in this case. So that is what you're going to have at the end. Just divide the two. So y bar is going to be the second area moment. Let's just say the second moment here, guys. So just not have here over the first moment, just like that. Moment, this is moment. Okay, not moment, but moment. So the second moment we are given as 213 meters to the exponent of 4 over the first one is negative 60. Here we obtained negative 60 here. That is what you obtained. So you're going to divide these two. So as we can see here, the cubic meter and the meter to the exponent of 4 cancel, and we are going to have our answer in meters. So it's going to be negative 3,55. That's what you're going to obtain, negative 3,55. So actually the negative there is because of what, the one that we are using. We used our tank as it was below the x-axis. So that is what we had. So these are the typical questions, guys. As you can see, that's how they actually ask, especially if you are referring to this question 5, where you are going to know that that part actually you're going to be working with 40 marks. So it needs a lot of revision to work with the question papers so that you'll be able to understand how to attempt these typical questions. But as you saw, guys, these are the questions that we had from this paper. So if there is any part that is not clear, let me know on the comment section so that we can at least try and work on it as we move on into our revisions, preparing ourselves for the exams. Yeah, let me know, guys, so that we'll be able to revise as much as we can with the season that we are left with. And that's how actually you're supposed to have this. So any other questions that we see that they are still having challenge, we can actually work on them. But that's it for now, guys, for Mason African Motives. Till we meet again.